Let's come up with a formula for finding the area of a parallelogram. But first, let's make sure you remember what parallelograms are. Which of these quadrilaterals are parallelograms? To review different kinds of quadrilaterals, click over here. Right, these were the two parallelograms. And this one over here happens to be a rectangle because all its angles are right angles. Let's take a closer look at the parallelogram over here. And let's find the area of this parallelogram. Suppose the length of its base, meaning this side on the bottom, is b. That means the side up here also has length b. And let's say the height of this parallelogram is h. By height, we mean the length of this line between the top and bottom sides that's perpendicular to both sides. Notice that the height of the parallelogram is the same all the way across the parallelogram. Let's leave the height over here. Notice we have a triangle on this side of the parallelogram, and let's move this triangle over to the other side. This new shape has the same area as our parallelogram. Now what kind of quadrilateral is this new shape? It's still a parallelogram, but can you be more specific? Exactly right. By moving this triangle over, we've turned our parallelogram into a rectangle with the same area. Now this rectangle has a base b and a height h. So what's the area of this rectangle? And click down here if you'd like to review how to find the area of a rectangle instead. Exactly. The area of this rectangle, which is the same as the area for our original parallelogram, is b times h, that is, base times height. And that's the general formula for the area of a parallelogram. To find its area, you multiply its base by its height, which is the length of the perpendicular line connecting the base to the opposite side. Let's try an example. Here's a map of the state of Tennessee with all its counties. Tennessee kinda looks like a parallelogram. The base is about 420 miles and the height of the state is about 100 miles. So what's the approximate area of the state? That is, about how many square miles are there in Tennessee? Let's find a formula for the area of a triangle. First, let's quickly make sure you remember what triangles are. Which of the polygons here are triangles? If you're not sure, click down here to review. Okay, great. Now let's say you have a triangle like this one here. We've positioned the triangle so that one of its sides, this one, is lying horizontally. Let's make a second identical copy of this triangle and flip it around so they have this side in common. Now what kind of quadrilateral do these two triangles form together? If you're not sure, click down here to review the names of different quadrilaterals. Exactly. Two copies of this triangle make a parallelogram. Let's say its base has length b and its vertical height has length h. Now what's the area of this parallelogram? If you're not sure how to find the area of a parallelogram, just click over here. Nicely done. The area of a parallelogram is base times height, so that's b times h. Now remember that we combined two identical triangles to make this parallelogram. So what fraction of the entire parallelogram's area does our original green triangle represent? Right. The green triangle represents half of the parallelogram. So the area of the triangle is 1/2 times b times h. And notice that just like in the parallelogram, b represents the length of the triangle's base and h represents the length of the triangle's height. So it turns out that for every triangle, the area is 1/2 times the base times the height. By the way, any line like this one here that connects one corner of a triangle to the opposite side and is perpendicular to that side is called an altitude. Okay, let's take this 1/2 base times height formula for a spin. Say you have a triangle with a base of 7 and say this altitude has a length of 4. What's the area of this triangle? Well done. Next, consider this triangle whose base is 6. Now remember that the altitude connects a triangle's corner, or vertex, to the opposite side and is perpendicular to that side. For this triangle, this altitude actually lies outside the triangle. But that's totally okay. our formula of 1/2 base times height still works because every triangle, even this one, can be doubled to make a parallelogram. Let's say this triangle has a height of 5. So what's the area of this triangle? Great! Let's try one last problem, which may be a little trickier. Here's a right triangle, meaning it's a triangle with a right angle. And let's say its legs have lengths of 6 and 8. It turns out that the longest side of this right triangle has length 10, which you can find using the Pythagorean theorem. Let's draw in another altitude for this triangle from this vertex to the side with length 10. What's the length of this altitude? There are a few different ways to find this answer, but perhaps the best way to go involves finding the area of this triangle 2 different ways. Click here if you're not sure how to get started on this question. Okay, no problem. First, let's take a closer look at these 2 sides of the triangle. The base has length 6, and this side is actually an altitude of the triangle, so the height of this triangle is 8. Try using these facts to find the area of this triangle. Nicely done. So the area of this triangle is 1/2 times 6 times 8, which equals 24. Next, let's focus on the side with length 10 and this other altitude over here. Let's call the length of this altitude x. You can think of this side as being the base of the triangle and this altitude as the height. So try finding another expression for this triangle's area in terms of x. Exactly right. The area of this triangle equals 1/2 times 10 times x, which equals 5x. So now you found the area of this triangle 2 different ways, finding that it equals 5x and that it also equals 24. So 5x must be equal to 24. Try solving this equation to find the length of this altitude in the triangle. Well done! So this altitude has length 4.8. So once again, here's the general formula for the area of a triangle. For every triangle, its area equals 1/2 times the base times the height.